Greetings. This week we are in 5th grade working on number and operation, specifically with fractions. Just like in 3rd and 4th grade, fractions have a lot of information entailing, so we're going to take in a whole week just with fractions. And as you can see, within this domain there are many different standards that need to be covered. So we're just extending our knowledge from 4th grade into 5th grade and using still more diagrams and models. And I'm hoping that you'll see some models this week that you haven't seen before, and perhaps even some aha moments. So I look forward to hearing your thoughts on these things. All right, Rollo and Zeus agreed to train for a walkathon together. Rollo walked 2/3 of a mile. Zeus wants to walk the same distance, but the trail near his house is marked every 1/6 of a mile. Use a number line to show how Zeus can be sure to walk the same distance as Rollo. So here's Rollo's distance. I have a full mile broken into 1/3 pieces so that I can determine that 2/3 is 2 copies of 1/3. Zeus's distance, his trail is marked every 1/6 of a mile, so I have the exact same unit of 1 mile, except this one is broken down into sixths. So in order for me to go the same amount of distance, Zeus would need to walk 4 copies of 1/6 of a mile to be the same distance as Rollo. So then we ask ourselves, 2/3 equals how many copies of 1/6? Well, it would be 4 because we hopped 4 times to get to 2/3. Also, I can see that if I were to multiply my numerator and my denominator by both 2, I would also get 4/6. Here's a record of a class walkathon, distances for each day. Which students walked the same total distance? We're going to explore this using fraction strip models. So I'm going to pull up a fraction strip manipulative, virtual manipulative I should say, and there are fraction strips that you can print and color off on your own in our manipulative folder too if you'd like to have something tangible. Okay, so using one of the virtual manipulatives, I have the option of using fraction tiles, decimal tiles, or percentiles. So we're going to use the fraction tiles for now. As you can see, there's a whole unit and then broken into halves, thirds, etc. Alicia, her distance on day 1 was 2/8 of a mile, so I'm going to put 2 copies of 1/8 here. And on the second day, she walked a half a mile. So now I'm going to put 1/8 plus 1/8 is a half. So there's Alicia. We also need Brad. He has 4/8 on his first day. This is also a great opportunity to use these because we can also see that 4/8 is also the same as 1/2. So when talking about equivalent fractions, which we're going to get to here in a moment, and then he walked 12/16. We don't have 16ths. We don't have 12/16, but we could do 6/8, 6 copies of 1/8. So I'm gonna bring out 6 of them instead to represent 1, 2, 3, 4, 5, 6. Okay. When I close this fraction bar, I'll be able to move them over so we can see them better. Connor walked 2/4 on his first day. 2 copies of 1/4. And on his second day, he walked 6/8. So more of them eighths. 1, 2, 3, 4, 5, 6. Dan walked 1/4 on his first day and 5/10 on his second day. 1, 2, 3, 4, 5 1/10. And Elena walked 5 1/10. 1, 2, 3, 4, 5, and then 3/4 on her second day. All right, so let's line these up and see who, oops, that we didn't need that one. Who walked, we don't need this one. All right, oops. All right, so we'll put him here, but we'll ignore him. Okay. Line them up a little better so that we can compare them. Notice when we move into 6th, 7th, and 8th grade and we start converting fractions to decimals and percents, it's already doing some of that for us that we can kind of get an idea of what those mean. Looks like we're already starting to match some of them up. It looks like Brad and Connor, even though their fractions are different, their combinations of fractions are different, they're still equivalent. The same looks to be true here with Alicia and Dan. We can see that 1/4 matches the same amount as 2 1/8, and 5 1/10 is the same as 1 1/2. Let's see if Elena matches anyone here. It looks like Elena is going to match and do the same distance as well as Brad and Connor. We see that 5 1/10 is the same as 2 1/4, and that 6 1/8 is the same as 3 copies of 1/4. So these fraction tiles, even though again that they're different measurements, at the end they're still the same length. So expressions with sums and differences of fractions can be written in different ways using equivalent fractions. So 2/8 plus 1/2 is the same as 1/4 plus 5/10. All parts of the equation are equivalent because the fractions have the same value even though they're using different pieces. So Joshua is on a team with Alicia and Dan, so they all walk the same distance. Choose 2 different fractions from the list below to write an addition expression that represents Joshua's difference. So I have 2/8 plus 1/2 equals 1/4 plus 5/10 equals what plus what? So looking at 2/8 is something that jumped out at me. I know that 2 copies of 1/8 is the same as 1/4. So that could be one of my question marks. Also, I see 3 copies of 1/6. That's equivalent also to 1/2. So we could use that one. And there are many others in our list that we could use too. This is just one example. Use 2 fractions from the list to create an equivalent expression to 3/5 minus 1/3. We will use our fraction bars to help identify which ones will work. So right now we have 3 copies of 1/5, and I want to know which one of those fractions in that box will work as the same as 3 copies of 1/5. Okay. Well, we first start off with 3 copies of 1/10. So 3 copies of 1/10. I'm just going to stick them right here on the top here. 3 copies of 1/10. Well, boy, that certainly is not the same. So the 1/10 is not going to work. 3 copies of 3. Well, that would be 3 copies of 1. Well, goodness, that's way too big, so those aren't going to work. 2 copies of 1/6. Oh dear, still not going to work. 6 copies of 15. We don't have 15ths, but let's do 6/10, see if that works. 6, 2, 3. I think we found our correct one here. So 2 1/10ths is equivalent to 1 1/5. So 3/5 is the same as 6/10. Let's do the same for 1/3. So we'll put our 1/3 up. Is that equivalent to 3/10? Bring my 3/10 up here. 1, 2, 3. And it's still just shy. There's not enough there. Close, but not quite. 3 copies of 1? No, way too big. 2 copies of 1/6. By golly, I think we found it. So 1/3 is equal to 2/6. So we found that 3/5 and 6/10 were the equivalent, and 1/3 and 2/6 was equivalent. All parts of the equation are equivalent because the fractions all have the same value. We learned in 3rd and 4th grade that as long as our pieces are the same size, we are able to find their sums and differences. So we know that 1/5 plus 3 copies of 1/5 would give us 1/5 shaded plus 3 more copies of 1/5 for a total of 4/5. But if I wanted to find the difference between 2/3 and 1/2, we are not looking at the same units. These aren't the same size. So what we need to do is determine what that size might be. Because if I start at 2/3, having a full unit line, and I subtract 1/2 from it, I'm not quite sure what's in the middle there. Because they're not the same, we can't add and subtract them together. So we need to make their pieces the same size. What we can do then is notice the yellow marks. We can split them, the thirds in half and the halves into thirds, so that we create sixths. And when I create sixths, I see then that 2/3 is the same as 4/6 because the same amount is shaded, and 1/2 is the same as 3/6. And notice that we cut the thirds into 2, so we multiplied by 2. We cut the halves into thirds, multiplying by 3. And now we can take 4/6 minus 3/6, so 4 copies of 1/6 minus 3 copies of 1/6 to get 1/6.